Populations and samples is about looking at a group of people that you are conducting a survey on and making sure that you do it in a manner so that your data is accurate. First, let's make sure you understand the terminology that I'm using. First, a population. This is different from the population you learned in geography class. It's the entire group considered for a survey. So if I were wanting to know the favorite food of 7th grade students across the United States, my population would be 7th grade students across the United States, not just here at North Marshall, not just in Kentucky, but of the whole country. A sample is a portion of the population used to study when the entire population is too large to study. So let's take that same example. I cannot survey every 7th grade kid in the United States. It would be way too much trouble to gather that data and way too much trouble to sort through and interpret that data. So what I can do is I can take a sample. I can take a smaller portion. Think about when you sample food. I'm not eating the entire meal to sample it. I'm just taking a portion of it. But if I were having mashed potatoes and gravy, I wouldn't want to just take a sample of the gravy because I'm missing the taste of the potatoes, or vice versa. I wouldn't take just the taste of the potatoes. I need a little bit of the potatoes and a little bit of the gravy to have an accurate sample. So when you take samples, there's two different kinds that you can have. First, you can have a random sample. This is where each person in the population has an equal chance of being selected. Whereas a convenience sample is based on members of the population that are readily available. Let's go back to our example. Favorite food of 7th grade students across the U.S. A random sample would mean that I pick randomly one school from every state across the U.S. I'm not picking the school that has the most students. I'm not picking the school that has the highest income per capita. I'm just randomly selecting one school from each 50 states. A convenient sample would be I just ask students at North Marshall. So you can kind of see where the problem may lie. In North Marshall, our favorite food might be fried chicken, or our favorite beverage might be sweet tea. But if you go up to, let's say, Seattle or Michigan or Los Angeles, they may not eat things like fried chicken, and a lot of times they don't drink sweet tea because that is a regional dish. That is something that around here people like. Or if you went down south, let's say in Louisiana, they might like crawfish, and that's their favorite fish. Where around here, a lot of you have never even tried crawfish before. Here's the bottom line. The more random the sample, the more representative it is of the population. I don't want to pick what's convenient to me. I want to take a sampling from all over the entire population. I don't just want to pick what is nearby. Also, the more people, the more objects in your sample or in your population, the more accurate your data will be. If I only surveyed 5 kids across the entire U.S., that's not going to be near as accurate as if I had sampled 500 students across the U.S. So a general guideline, the more random the sample and also the more people in my sample, the more accurate my data will be. So let's analyze different sampling methods. So let's say we're wanting to know about football game student attendance. Here's a couple of sampling methods, a couple of ways I could go about doing that. One way is I could pick 80 students selected randomly from the school directory. I go through the yearbook and I pick one student on each page. I pick the 10th person on each page, let's say. And the results of that survey are 62% of those students attend football games. The other sample is we have a guy named Bill, and he surveys 28 students sitting near him at lunch. And of those 28 kids, 81% of them attend the football games. You can see how I have different results of my survey. Survey A is the most accurate because it is more random. If you think about Bill and think about yourself and the people you sit with at lunch, typically you have the same interests, and you can think about the tables at lunch. Think about there's a certain table probably that those people go to football games, and there's other tables where people have never went to football games because different kids have different interests, and you usually spend time with the people with common interests. You can also kind of think about how when you hear different statistics in the media, it could be skewed. When they say, 4 out of 5 dentists prefer Colgate toothpaste. Well, how random was that sample? Did they go to a dental school where Colgate had a contract with that dental school and ask them what their preferred toothpaste was? We don't know. We don't know how random their survey was. So when you see statistics in the media or in marketing, you need to really think about it and don't just take it for the face value. Next, let's talk about a biased sample. Bias means that it does not fairly represent the entire population. So here's a couple of samples, and we're going to determine if each sample may be biased and explain that. So you're going to see a correlation between a convenient sample and bias, and a random sample eliminates a bias. First, you have 50 people exiting a movie, and they are surveyed to find out what type of movie people in the town like to see. I would say that that is bias. And I'm going to say that it is biased because if people are leaving that movie, they're leaving a movie that they like to see. An example would be, let's say that Frozen has just come out in the theater, and you're asking those people that leave the theater, what type of movie do you like to see? They're probably not going to say that they like to see, sci-fi movies, or they like to see drama and action or war movies, because the people that are at Frozen are mostly children, and children typically don't enjoy a war movie. So that is not representative of the population, which is people in the town. Second, a librarian randomly chooses 100 books from the database to calculate the average length of a book. This is not biased. It is not biased because the sample was randomly generated. When a computer is doing the work, it's going to be more random, and you're looking from a database. That database has every book in the library. If that librarian had just went to the nearest shelf and selected, what if that nearest shelf was the children's books? And those books typically aren't more than 10 to 15 pages long. And if you just took your sample from that shelf, you're going to have skewed data, because we know that most books in the library are more than 15 pages long. Or who's to say that she didn't go to the encyclopedia shelf and there are 1,500 pages in those books? Well, we know that books in the library are not on average 1,500 pages. But if she chooses 100 books from the database, you're going to have a sampling of all kinds of books. You can use a proportion either to verify claims based on statistical data, or you can use it to predict information based on statistical data. Here we're going to verify. A biologist estimates that more than 700 of the 4,500 elk at a wildlife preserve are infected with a parasite. A random sample of 50 elk shows 8 are infected. Determine whether the estimate is accurate. You can see how I've color-coded my proportion. Remember from solving proportions, it's easier to line things up if you have your corners labeled. The first ratio, the top, is the infected in the sample, which is 8. We have 8 elk that are infected. Underneath that is the sample size. The sample that was collected was 50 elk, so 8 out of those 50 elk. And we want to see, is that proportional to the number that's infected in the entire population, which has been estimated at more than 700, compared to the population size. The population size is 4,500. The estimate is what we are verifying. Determine whether the estimate is accurate. So I'm going to put an X here where the estimated infected in the population would go, because I want to see, is the value of X what will be proportional? Is that pretty close to more than 700? So let's go about solving this. If you'll remember from solving proportions, you do this by cross multiplying. So multiply 8 times 4,500, and you get 36,000. I'm going to scoot down here to do this. Multiply the other diagonal, 50 times x, 50x. Now I'm wanting to isolate x, so I'll undo what's happening to that by dividing both sides by 50. And 36,000 divided by 50 is 720. So let's compare that with our estimate. He estimated more than 700. 720 is more than 700 and it's close to it. So we're going to put a check mark here. We're going to say yes, that was an accurate estimate. Now let's practice what we've seen this lesson. For the first two questions, I want you to determine whether each sample may be biased and explain why or why not it's a biased sample. And on the last one, you're going to predict the number of students that speak 3 or more languages using a proportion. Go ahead and pause the video and try that out. On practice A, it says Apple randomly selects 500 customers from its customer database and surveys them to find out how they like their customer service. This is not biased. I know that because the sample was randomly generated. It says Apple randomly selected. It's from its computer database, so it's all of its customers, whether they were satisfied or not. It's not looking at Apple's website and looking at customer reviews, because if that were the case, Apple would be only selecting reviews to post that were positive reviews. This is pulling from their computer database, not just satisfied customers. Part B, a DJ asks the first 10 listeners that call in if they like the song that was just played. This would be bias, and that's because listeners like the music being played because they chose that station. Someone listening to a country station would naturally not like a pop or a jazz or a bluegrass song a lot of times because they chose a country music station. If they're going to like what is being played because they, on the most part, because they chose that station. It was a convenience sample, not a random sample. On Part C, UK has 30,600 students. I don't know if that's true. I made that number up. In a random sample of 240, 20 of those speak 3 or more languages. Predict the number of students at UK that speak 3 or more languages. So I started by setting up a proportion. 20 of the 240 in the sample speak that language. So we're proportionally going to see how many out of the entire population, 30,600, speak 3 or more languages. Solve by cross multiplying. 20 times 30,600 is 612,000 equals the other diagonal, 240 times x. Solve that by dividing both sides by 240, and you get x equals 2,500. And actually, I wrote that wrong. That should be 550. There we go. 2,550 students would be an accurate prediction.